Hello, welcome back. So today, as part of a data modeling masterclass series, so we are bringing one more video, and this is the continuation of the previous video, we can say, which we discussed in the previous video regarding key elements of logical data model, right? So there we discussed couple of points like entity, attributes, partitioning, and like normalization and other details of key elements of logical data modeling. Uh, but so in this particular video, we will discuss more in detail about entity and attributes, and we will take a example so that it can clear the doubts that you might have, and especially many people are confused about one to one, one to many, many to many. What kind of relationships are these, and how do we understand these relationships? So that also will be explained in this video in detail, right? So let's get started. Before proceeding, if you are new to the channel, we would recommend you to please subscribe and also press bell button for instant notification. So first, let's explain what is entities. So entities, as we have seen in the previous video as well, is it represents the key object or concept within the domain being modeled. So these objects are typically nouns and can be tangible. So this second part we will come, right? But if you understand the first part here, so entities are key objects or concepts within the domain. So domain means what? Like you might be working in a retail, you might be working in a pharma industry, you might be working as a ERP in the ERP domain. So in each domain, so we have their own key objects and their own concepts. So if you take retail, so there will be transaction, customer, product, order, whatever, right? And if you take say for example pharmaceutical, so there might be instruments, right? There might be patient record, doctor records, there might be experiments, table, so whatever, right? So that is what we call it as a domain being modeled, right? And these objects are typically nouns and can be tangible. So noun means like you can consider it's like a person or a product, right? And it can be intangible also. So like say for example transaction or event. So how do we take an example, right? So it can be a, so if you want to take example of noun and it can be a tangible, right? So person or a product. So here it can be a person, right? Person means it can be a customer, right? And it can be a product also, product table also you can consider, and it can be intangible also. Tangible means uh, like like a transaction or event, right? So intangible. So example of intangible is again order. So here, so if you take a customer and which is a tangible and order is a intangible, so what that tangible intangible means, right? So customer is not dependent on anything, so it's a tangible object. But order is dependent on customer. It is an intangible object, right? Because it's an event basically, which is happening. And so if you take customer as an example, which is an entity here, and it can represent individuals or business purchasing products or services, and a customer can have attributes like customer ID. So this is very important. At least one primary key column should be there. One column which represents the primary key should be there so that it can be uniquely identified. And then you can, based on your requirements, you can define another other columns like name, address, email ID, phone number, etc., etc. And similarly, when it comes to order, so it used to represent a transaction or a purchase made by a customer. So again, you can have a uniquely identifiable attribute here that we call it as order ID, and other attributes you can define. And again, this is important, right? Foreign key. So this is where you define a relationship between customer and order. So without this foreign key, so you cannot link these two, right? That means each order is having a customer ID. So that customer ID is nothing but it is a primary key in the other table. Okay, and what is the total amount, whatever it is, right? So this is about entities. Hope so. Just have this concepts one by one. So these are very simple concepts, but you cannot rush understanding these concepts, right? And characteristics of entities. So there are a couple of characteristics you can think of, like each entity must be uniquely identifiable within the data model. So if you define a table called as say customer, so that particular, so you define the table as cust, right? So table name is cust. So this particular cust table shouldn't be in anywhere else. So take example of an enterprise level project where you are having hundreds of thousands of tables, where you cannot have, you need to be very careful in defining the names. So once you define the name as customer, so you cannot use it in anywhere else. So that means you need to be very careful using this. Otherwise, you need to end up renaming the tables and renaming all the applications which is point using these tables. So that is where it is important to uniquely identify a particular entity and make sure you give the proper name in the first place. So if you are doing a practice and all, it doesn't matter, right? But if you are doing an enterprise level implementation, so each and every details is important. And how do you define a name? What is the naming convention you use? So you need to think about a feature perspective, and you need to think about the product perspective, what exactly you want to build. So then only you can come up with a unique name for the entity. And what is instance? So instance is nothing but it is an entity comprises of multiple instances or record. For example, the customer entity may have records for each individual customer, right? And then you have a attribute. So attribute, and these entities are defined by their attributes. These are the data points that provides more detail about the entity. So entity means these are the columns, right? These are the key characteristics of entity. That means if you want to call up table, or if you call something as entity, so that means this this characteristics should be there in that. Okay, and what are the types of entities? So basically we have two types of entity. There is strong entity and weak entity. What that means, right? So strong entities means these entities exist independently of other entities. For example, product entity, right? So product entity can exist without needing any other entity. Okay. Or say for example, customer entity. Customer entity also doesn't need any other entity to support it. But however, if you want to uh, take example of order entity, right? So that will become a weak entity because these are entity depends on other entity. So order is dependent on customer, right? So they often do not have any unique identifier or rely on the foreign key. For example, order table, right, can have order item might depend on the order. Okay, so that's the like different types of entity. Okay, so hope this is clear, right? Strong entity and weak entity. Example: customer is a strong entity and product is a weak entity, or order is a weak entity, which is dependent on the customer. And then so attributes. So attributes are are the properties or characteristics that describe an entity, and each attributes hold a specific piece of data about an entity instance. Okay, attributes, this is just nothing but a columns in the entities, right? So and it defines uniquely. It defines uh, the it defines the entity, you know, and characteristics of that entity, right? Suppose you can name the table as customer, but what is the characteristics of the customer? So whether he is having a phone number, whether he's having a date of birth, whether he's having an email ID, whatever, right? Date of birth, what is his age? So all that will be defined by attributes. So you have a customer key, customer ID, and it need to be a primary key. That is a required column. Okay, and you have a required means it's a mandatory column. So first name and last name are mandatory columns, and email ID is optional because your customers might not have email IDs. Phone number also is optional. Date of birth is optional, but it is having a data type of date, right? And address is again one of the important attribute here. Is we call it as a composite attribute because it is having a sub attributes here. Address can have street. Address is a combination of street, city, state, and postal code attributes. So it is a combination of attributes. That's why it is called as a composite attribute. Okay. So whatever you see here, these are attributes, and this particular customer is an entity. Okay. And so when we are defining any entity attributes, right? So you might have observed. So you need to know why we are defining this with this description. Okay, and you need to know whether it is a mandatory or non-mandatory. We need to define that in the table, what is a data type, and whether it is a primary key or foreign key, or it's just a it is just a column without any constraints. So you just need to mention all those, or um, finalize all those details when you before creating the table, right? And now if you look about the characteristics of attributes. So characteristics of attributes are like atomicity and data type and optionality, and then you have a default values. So what is atomicity? Atomicity is nothing but each attribute should hold a single piece of data. For example, an address might split into multiple attributes such as street, city, and zip code, right? But each attribute should always have a single piece of data. So it should not have the combination of all those things. Otherwise, it will be quite confusing when you are doing any kind of reporting or analytics, right? So that's the meaning of attribute. So attribute is a atomic value we need to consider there. Okay. So instead of creating address, you what we are saying is to create a street, city, and zip code, so that it will be more atomic as possible. And data type, each attribute has defined data types such as integer, string, date, etc., etc., which actually dictates the kind of data it can hold. So that is nothing but a data type. And next you have a uh, optionality. So optionality is nothing but so attributes can be mandatory or optional. So mandatory attributes must have a value for each entity instance, which optional attributes can be null, right? And you have default values. So default values, some attributes may have a default values if no values is provided, right? So if you go back here in the screen, right? So here we have mentioned, right? So it's a mandatory column. These are all mandatory constraints, right? And optional means it is not required. It's not mandatory. And all the attributes need to have a data type. And default values is suppose you can fill a value whenever you make an entry, and if there is no value provided, right, you can default it to some value. Suppose a salary column if left blank, you can make it as 0. Okay. So suppose a date of birth column is left blank, you can put some 1900 or something values to denote that is a the date of birth is not provided. So that again depends how your system want to have the default values, or how you want to maintain them. And again, types of attributes. Simple attributes. Uh, we have couple of attributes here. Simple attributes are nothing but these cannot be divided further. For example, if you take a first name, right? So first name is a simple attribute, and you cannot like split the first name into further atomicity or further level. And a composite attribute, you can split into multiple parts. Suppose you have a full name, right? Full name can be split into first name and last name, right? And there are other attributes like derived attributes. So these are not stored but can be derived from the other attribute. For example, age, right? Age of a customer or an employee can be derived from his birth date. Okay. And similarly, you can even derive the, say for example, salary based on some calculation. So maybe the location, based on the location, based on the job group level he is in. So based on that, you can multiply or whatever calculation you can perform, and you can derive his salary. So those are like derived attributes. And you have multi-valued attributes. So these can hold multiple values. Say for example, phone number, right? For example, a particular customer may hold a multiple phone numbers, right? A single customer can have multiple phone numbers. So that's the best example of multi-valued attribute. Okay. And now let's take an example in detail, and we can explore how exactly the entity and attributes in a logical data model look like. So to complete this combination of entity and attribute, what is important is relationship. So relationship defines how entities interact with each other. So they specify the cardinality. So this is another important word, right? So cardinality is nothing but it might be one to one, one to many, right? One to one, one to many to many, and can include attributes. Say for example, it can include attributes like order contains multiple products. One order can have multiple products. So that is a one to one, right? So one order can contain multiple products. It is one to many. Okay. That's one example of cardinality, right? And there might be other cardinalities we will see in detail in the next coming slide. So relationship type include one to one, one to many to many, etc. So there are other complex relationships also like zero to many, zero to one, etc. So we don't want to make it complicated. So and those are also rarely used actually. So these are the most commonly used one to one to many to many. So that's why we will cover that in this video. Great. So now let's take this author table and a couple of tables like author. We have author ID, first name, last name, his birth date, and these are the data types. And author ID we are defining as a primary key if his first name, last name, birth date. Similarly, we have a book table, so where we have a uniquely identify a book here using book ID, that is a primary key. And you have a title of book. ISBN is nothing but an international standard book number, so you be calling it as ISBN. Author ID is again a foreign key reference of this particular coming from this table, right? So then we have a library branch. So library branch is again, it has a branch ID. So every column should have ID as you can see here, right? Which can eventually identify a particular identity. So then you have a branch name, name of the branch, and address, physical address of the library branch, and you have manager ID. So who is the manager for this? Okay. And then you have member. So member is nothing but whoever wants to purchase or whoever want to lend the book, right? So member ID, first name, last name is email IDs. Okay. And then you have a loan ID. Loan means you want to borrow that book, right? So what is that borrow ID, member ID, book ID, loan ID, return ID, whatever. Then you have a library manager. So library manager is having a library ID, first name, last name, email ID, whatever. So then, so these are the tables if you want to build, suppose a library management system. So these are the, say for example, entities we have identified during the logical data model. So what is the next step? So next step is we need to build a relationship between them. So so we will just simplify this table by just removing the data type and the description. So this is the author table and these are the attributes, book table. Similarly, all this whatever we have seen in the previous slide. So we are just bringing the attributes here. Okay. So now we want to build the relationship. Which entity is belonging to or having a relationship with Azure and other entity, and what kind of relationship it is having. So if this author is having the relationship with book, what kind of relationship? One to one to many to many, what kind of relationship it has? So that we need to logically define here, right? In this step. So how do we define that? Let us see. So let's take this author and book. So the relationship between author and book is one to many. So why we say that it is one to many? Because one author, right, can write multiple books. So that's why you have a book and author ID here, book ID and author ID. So here he can write multiple books, right? So that is why you have one author writing multiple books here. And next you have one to many. That means one member can loan, can have multiple loans. That means he can borrow the book multiple times, right? That is why it is one to many. Okay. And it cannot be other way around. So we will understand if it is other way around. So it will become, if you are like, let's take another example, right? So loan to book, right? See, one borrow. So suppose one member is borrowing one loan. That means this is a person who is say his name is XYZ, and this XYZ is having a loan ID 1 here, and under this loan ID, okay, so he can have a number of loans, right? And loan 1, loan 2, third day he can do loan 3, fourth day he can do loan 4, etc. So on the loan 1 which he did on the first day, he can have again n number of books, right? Book 1, book 10, etc. Right? Here in the loan 2, he can borrow book 100, he can borrow book 23, whatever. That means, so from XYZ to this loan, it is, as you can see, one to many. And again, from loan to book, it is one to many. So that is why this also is one to many, and this also is one to many. Okay. So now let's moving on one to one. So this is again interesting, right? So why we are saying it as one to one here is one branch can have only one manager. So this is library branch, this is library manager, right? So it's always one to one. So one branch cannot have more than one manager, right? So that is why we call it as a one to one relationship here. And finally, we will understand many to many. What is many to many is, suppose you are having a library branch, right? And that library branch can have multiple books, right? So this particular branch can have like branch ID is 100, and this particular branch ID 100 can have say book 1, book 2, book 3, book 4, book 10, okay? And in the other way around, so let's take example of book ID 10, and this book ID 10 can be in branch 100, branch 200, branch 400. So it's other way around also it is true. So this is one to one, one to many. Again, this is one to many. That's why we call it as a many to many here. And so these notations are important here. So it is a double arrow, double-headed arrow. So this is one to many is a single-headed arrow, and one to one is not having any heads. So that's the representation, right? And this is many to many relationship, what we are calling. And so here, if you want to define a many to many relationship, how do we do that? So it can be done using some dummy table here. Okay, you can create a book library, a book library integration or book library relationship table, whatever you can call it. And here the important thing is you need to have a book ID and you need to have what? Branch ID. So if you have book ID and branch ID, and there is no concept of primary key and this one right here. So you just need to have book ID, and each book ID will have a branch ID and other way around. So this will maintain that. So then you can establish the relationship between these two via this table, temporary table or dummy table, what we can call. So that's end of the day. You need to logically understand this. Implementation is secondary, right? So implementation we can do using some table or whatever, but logically you need to understand and derive it as properly as a many to many relationship. Okay, hope this is clear. So if you have any questions, please drop in the comment section. I'll try to answer in the comment section. Okay, importance of proper definition. So why we need to have this definition of creating entities, creating attributes, relationship? Why are we even doing this? So the reason is these three things, right? So we need to have a data integrity to ensure that each piece of data is correctly related and consistent. So if you are building a example, you are building a complex ERP system, understand what kind of entities it can have, what kind of detailing it needs, right? What number of tables it can have, right? And what are the relationship between all of these tables? It's very crucial to understand each and every piece of the data, right? And so that will actually promise you the data integrity, or it can ensure the data integrity is in place. And the scalability, right? So suppose like we are working in the agile world, so most of the projects are working in agile mode, and the column can be added, removed, entity can be added, removed, right? So in that case, you need to have that facilitation, or you need to have that um, scalability, or you need to have that adaptability in your data model, which actually adapts to the changing needs. So that will facilitate the easy addition of any new attributes and entities, or as a business needs evolve. So you cannot design a data model which is very rigid, right? So it need to be agile, it need to be flexible, particular data model. Okay, and the data model also brings the efficiency. So because you're performing, you're identifying and doing some normalization, you're building relationships. So it helps create, if since you have a foreign key relationships, so suppose you want to create build a report, right? And you cannot build a report with one table. You need to join multiple tables, and then only you can bring the data, required data in the reporting format. So in that case, so if you have proper relationships in place and you have proper partitioning in place, so that will, and you need to perform a normalizations, proper normalization. So normalizations in detail we will explain in coming videos, but that is so these kind of things will bring the efficiency for the overall project or product. So quickly summarizing, so attributes provide specific details about the entities, right? And including properties like names, dates, or identifiers, and can vary in different level of complexity from simple to composite. That means simple can be first name and composite can be address. So address, as we saw, it can be multi levels, right? Address can be go to multiple levels. And even relationships, right? Relationships is important, which defines entities, how entities are interconnected. So that will bring you the picturization of whether it is a one to one, one to many, many to many associations. So which will definitely help you to map out the structure and flow of data within the data model, right? So hope this was useful, and thanks for watching.